Right, the next talk is by Dr. Graham Smith from the Animal and Plant Health Agency of DEFRA, and he's going to talk on looking forward, mammal data and its potential at a national and international scale. Thank you.
Thank you. Okay, so first of all, I thought I'd introduce me in terms of what my job is. I work for Animal and Plant Health Agency. So basically, I'm there to make sure the government has got the evidence it needs to make rapid decisions on things like new diseases coming in, invasive species and stuff like that. So what's the best way of working this is what are the things we really need to know about to help make these sorts of decisions? So are populations stable? Where are they? Which is particularly important for things like disease risk and pest management. And how many are there? So all of the above reasons there. So we really need to know about things like national population size, but also its distribution and density, because that's a key component if we want to evaluate exotic disease introductions and things like that. We could also be concerned with trends over time, but that's more of a biodiversity issue in JNCC rather than a disease and population management issue. So what do we have publicly available? Well, we've got observations such as the NBN, and we've also got access to a lot of published studies on species density. So I thought I would explore how we can put all that together and see what the utility is. Can we estimate national population size for species of interest? Now, I'll give you the spoiler now. Yes, we can. We can actually get very good estimates of national population size. It's got large uncertainty, but just using that available data, we can get that estimate. And coincidentally, right in the middle of that estimate is the actual national population size, at least as far as one species is concerned, where we've got the maximum amount of data, it works. And the but. So all of this is pre-April. There were 84 different data providers with mammal records. We had to contact them to get it. It takes time to respond, so that's the first issue. If we want to do a risk assessment, we need to do it within a matter of a few weeks. The resolution at which we could get access pre-April varied, and each person could respond on their own. So that added a little bit of confusion to what's going on. In terms of published density estimates, it's actually very rare for people to publish a study and say exactly where they worked. They say on such and such a farm or in this woodland or Suffolk. It's not very precise. So there's a huge variation in site description, and then just going off the bottom of the slide there. There's very rarely a reference map of the study site, and none of them provided maps and the original data in any electronic format that would be easy to import to be used. But what can we do with it? Well, we have a modelling framework looking at species distribution models. So we've got access to a lot of environmental data. We take the occurrence records, and we run it through a suite of 7 different species distribution models with a training set and a testing set, and we work out which is the best of those models with that data. We then repeat that 100 times. We have 100 best models that we can then average, which gives us the habitat suitability for that species based on the occurrence data. How does the density data fit in? Well, if we know how suitable that habitat is, and generally, let's say we're doing it on a 1k square basis, because that's what the occurrence is on, we've got a study site is never 1k square. It might be a small portion of that. So the question is, the density you've measured in your study site, does that apply to the entire 1k or 10k square, which would give you a maximum density? Or does that species only occur where it's been measured, which would give you the minimum density? And thus, for each of the species, we have a minimum and a maximum For the majority of species, it'll be somewhere towards the middle. And we can think of reasons why it'd be towards the lower end or towards the upper end, depending upon whether it's generic or specific habitat requirements. So the objective was to be as systematic as possible. So rather than go through and look at each species and decide where it should be and do any subjective efforts, it's just use all of the available data and see what happens. And one of the issues, as I alluded to earlier, is the number of different data providers providing different things. So some of them didn't provide data, some of them gave all data at 1K, some have only let data at 10K. Is this an issue? When you're looking nationally, yes it is, and it becomes quite a complex issue. You can see the difference here at the top for loss of occurrence recording effort between the 1 and 10K resolution and loss of species richness where it's applied at 1 and 10K. Now, interestingly, yeah, we lose some data. Does it have an effect? Actually, for most of these models, I think it has quite a profound effect because instead of having an expected density of occurrences, one of them just goes down a bit. So an area might go down a bit because the data source isn't there. Well, the models will interpret that as going, it's not such a good area. Perversely, if you removed that completely and there was no data at all, the model would say, I don't know anything about that, and it tries to fill it in. So the models might actually do better if there's no data in small areas than if you get half the data. So here's some recent results for some selected deer species. So ungulate diseases are quite a concern and potential of coming in. And then on the right-hand side, we've got the total, which is deer density across GB. So that might be quite useful for calculating probability of roadkill. What diseases might turn up. I could give you a whole list of diseases that might turn up in the next few years, but probably the next one is one that won't be on the list. But we might be concerned with things like chronic wasting disease for deer, so we would want to know where they are so we could sample them. So some of the results and limitations here, we think that the results that come out are fairly accurate given the amount of data going in. We can fill in some of the missing data, but there's a limit to how it works, and I think the models are particularly struggling with where data is reduced rather than removed. So where there's regional data deserts, if you like, where the data is provided at different resolution, that provides a big issue here. So as far as we're concerned at doing national studies, biodiversity, if all information is submitted to a national repository, then it comes through at the same scale. It comes through with the same quality throughout. I'm a mammalogist, so Mammal Tracker would be a great option there. Some of the responses we had, sometimes it took 12 months before someone replied to say, yes, you can have the data. Would have got rid of the disease outbreak or not by then, so that wouldn't have been very helpful. What do the model predictions show? Well, we have distributions and population estimates for 58 mammal species. For those technically minded, MaxEnt, Random Forest and SVM actually come out as very good. The average area under the curve, so the kind of sensitivity of the model is 0.7, which between 0 and 1, it's better than random. So we're definitely getting somewhere. 50% of the abundance intervals that we estimated purely systematically included the sort of gold standard, which is 1995 estimate of the national population. Now, we don't know if that 95 estimate is correct, but half of them included that. What's interesting is those where the confidence interval went higher were all species where we knew they were increasing, such as deer. So this systematic approach gave a higher population estimate than the 95 estimate, and they're all increasing. So they're going in the right directions, which is interesting. There's an inconsistency in biomass when we're looking at low low resolution due to the limited data sets available. And you can see again the difference here as you move between what's 10K along the top and 1K resolution at the bottom. It can produce maps which look quite different. So species richness on the left is not too different. The predicted biomass, which is quite a useful indicator for things like the threshold density at which a disease might spread, actually varies depending upon the scale of the data. In terms of the regional effort in surveying for density, there's also quite some interesting results coming out of this. So the density survey effort on the left there, how many different species have been surveyed in those particular 10K squares? Well, there's a lot of effort in the south. There's very little effort in the north of England and southern Scotland. So we can actually use these results as well to identify where the gaps are. So in this case, there's some obvious places we could be going to start to measure species density. Some of the approaches that can be used are relatively simple and could be used as student projects. They could be used as local wildlife trust projects, so that some of these can be quite easy to fill in some of these gaps. What was encouraging on the right-hand side is a lot of the estimates are within the last 20 years or so, so a lot of that's actually helpful. It's more up to date, which is good. We can also apply this at a European level as well. So we took a data download from GBIF. So that's all the mammal records on the left in green and the elk distribution in red. The grey areas is where we don't have any data. Now, what we can then do is run the same suite of models and see what happens for the species distribution. And it quite interestingly, for this example, it uses those limited red data and predicts rather well across the area where there's no data at all. So this is what I mean, sometimes better having no data at all might actually be better for you. How do I know it's predicting rather well? Well, there is a European atlas, which again, it's not a systematic assessment. There might be errors in it, it might be out of date, but that's the distribution as it comes through, and you can see that it pretty much covers a lot of that really dark red-orange on there. So we get quite a similar overlap with what we might expect to see for where the model should be producing results. For other species at this scale, it doesn't work so well. So if I wanted to predict things like the invasive raccoon dog across Europe, there's quite a few points up towards Estonia, because that's where it's been. There's very few points as you move into Central Europe where the data is. It really doesn't work. There's not enough data points to be able to do that. But where there's sufficient data, these approaches seem to work particularly well. So there are some issues from April as we've moved towards the Atlas. I know these are going to be looked at and sorted in many cases. But I'm glad I did this with the old gateway, because we got a huge amount of data through that. So thank you to everybody that let us use it. It might be a little time before we can do it with the same quality again, but the next time we do it at that level, it should be a lot quicker and easier, because we can get all the data in one go. I would also, in terms of sensitive species, I would actually imply personally that there's no such thing as a sensitive species, there's only a sensitive use. So therefore, there are, if you want to do national assessments for conservation, the species isn't sensitive. You could really do with that data at the highest resolution. So it's not the data itself that is sensitive, it's the use you're using it for. How can people help? Well, ideally I'd like occurrence records to go through national schemes, so there's a consistency of data. I'd like more focus to go on density estimates for common species. There's almost no density estimates for rabbit. And in regions of low or zero abundance, how often do you estimate the density of something and say it's 0? Because people tend to like looking where there's lots of something occurring. So trying to get occurrence records and demonstrate something's absent or at very low density is unusual. If people are looking at densities, it would be really nice if you did it on a 1K grid square, the British National Grid, because that's how the occurrence data occurs. It's always difficult when you've got spatial data that overlaps differently. If not, you can at least make it representative of the 1K square. So there's no point doing occurrence data of one little woodland if you've got other woodlands and other habitat nearby. Try to make it representative of the area. And there are hopefully ways going forward, such as automatic data flow going into the NBN or through iRecord in due course. I appreciate this isn't going to happen tomorrow. But if there's camera trap images that have already been identified by someone, they could feed in directly. And I think the future is trying to import more of this data without us having to sit down and work through each of the records and verify them and work out what's happening. And the more we can get this automated data flow coming through, I think the easier, certainly the easier my job's going to be, and I suspect the easier a lot of people's jobs are going to be in using all this data. Thank you.
Thank you very much, Graham. We have a couple of minutes for questions, if we could, please. Yes, Teresa. I think you'll need a microphone. Do you want to come to the... Yeah.
Yesterday, you might remember that I'm at BTO, but I used to be at Cumbria Biodiversity Data Centre, so I did read this paper when it came out. Saw Cumbria as a big, terrible place in red because of, I've probably said no to the finer resolution data, or some people might criticism, whatever. But actually, the reason it looked like that was because we were one of the few counties who had put data on the NBN gateway at all, so the gap was a false gap, if you like. It's not that there's no data in those places, it's that the data haven't been shared. And obviously, as you said, everything's changing out the atlas, so there's no point in re-going over that. But what I did wonder was whether you thought of modelling, whether you looked at modelling the patchiness of the data, as in what was available, or whether you had tried just dumbing it all down, or
Yeah, so effectively we modelled it at two scales, the data which we got at 1K and the data which we had at 10K, and then we took everything at 1K and assumed it was 10K. So we had a 10K data set and a 1K data set, and we could see what the differences were. Don't be too concerned if you're slightly dark on that map, because the people that didn't respond at all and we had no data at all didn't have data at 10K or 1K, so those aren't show and tells on that map. So the ones that never got back to us are not marked up. Perhaps I should have put them with little stars or something. But.
Did you compare the 10K analysis with just using a national data set?
Yes, so a couple of responses to that. First of all, without doubt, one of the issues over 10K is for mammals, very few species actually select a habitat at 10K. 1K seems a good one to cover most of the mammal species. And therefore, when you're trying to predict the density in a 10K square, you're multiplying up the survey into a huge area. So the uncertainty bounds at 10K data are always going to be huge. So 1K data is great. The example where we actually ended up with the best predictions were actually for the badger, not entirely because of the NBN data, because quite a few people said you can only have that data at 10K square, but the data we did get, we could supplement because we actually ran the National Badger Survey a few years ago, courtesy of Joe, who was involved in that, and produced the estimate of the national badger population, 485,000 in England and Wales, our estimate bounded that perfectly where we added all the extra data in. So I'm very confident that if all the data's there at a good enough resolution, we will get good answers out of it.
Okay, thank you very much again, Graham. And